Let's look at how we can solve this quadratic equation by using the method of completing the square. So when we're using the method of completing the square, our goal is that we're trying to rewrite this equation into the form of a quantity squared equal to just a number. So that's the format that we're going for. So inside of those parentheses we'll have our variable x as well as a constant, and on the right hand side we'll have just a number. So to do this, to build that perfect square for the left-hand side, the first step is that I'm going to move this constant over to the other side so that I can find a new perfect constant that helps me out when I'm thinking about my factoring. So I've got x squared minus 6x. Then I'm going to leave a space because I'm going to find a new constant to write there. I have my 11 now on the other side. I'm going to leave a space there as well because whatever I add on the left hand side, I need to add that same value on the right hand side. So the way that we can find the perfect constant to put in that left hand side so that it factors to a perfect square is always to look at the number in front of the x. So in this case it's our -6. And we're going to do two things to that number. We're always going to divide by 2. So if we take -6 and divide by 2, we have -3. And then we're going to square that number. So -3 squared is equal to a +9. So what I'm going to do is I'm going to add 9 on both the left-hand side and the right-hand side of my equation. So as long as I do the same thing on both sides of the equal sign, my equation is still balanced. So now look at this left-hand side of our equation. This is a trinomial that we can factor. We think about two numbers we know that multiply to 9 and add to -6, and we could factor that as x minus 3 times x minus 3, or we could write that as x minus 3 squared since it's two copies of the same factor. On the right hand side, 11 plus 9 is equal to 20. Kind of one little tip or a hint, whatever number ends up right there, in this case for us it was that -3, that will always be the same number that you got when you divided by 2 when you were working on figuring out that constant. And so it'll always work out in your factors. So we had a -3 and a -3. That value will always match up with what we had when we divided by 2 on that middle term. So now we've got our x minus 3 squared equal to 20. We're going to use our square root property that says if you take the square root of the left-hand side, it'll be equal to plus or minus the square root on the right-hand side. So we're taking the square root of both sides of our equation. We need to remember that plus or minus in there to get our two solutions. So on the left-hand side, the square root and the square cancel out. So we have just x minus 3 and then plus or minus the square root of 20. Square root of 20 can actually be simplified a little bit further. If you think about the number 20, 20 is 4 times 5. So we could think of this as the square root of 4 times 5, which we could even split into the square root of 4 times the square root of 5. Now 4 is a perfect square, meaning 4 is a number times itself, so 2 squared. So when we're looking at these numbers inside of the square root, we're looking to see if they're divisible by a perfect square. So numbers like 4, 9, 16, 25, 36. If they are divisible by a perfect square, it allows us to simplify this radical because the square root of 4 is just 2. The square root of 5 is just going to stay as is. So we have x minus 3 is equal to plus or minus 2 root 5. And then we're going to add 3 to both sides to isolate our x. So x is equal to 3 plus or minus 2 square root of 5. So this is giving us two solutions. You could think of this as 3 plus 2 root 5 and also 3 minus 2 root 5. We're just writing it in that compact form with the plus or minus. So the idea behind the strategy of completing the square is to rewrite the left-hand side of our equation with our variable as a perfect square So we're trying to write it as a trinomial that we can factor as two copies of the same exact factor, so that we can write it as a factor being squared equal to just a constant. Once we have it in that form, we're able to use our square root property to take the square root of both sides and then solve for x from there.